See, first of all, I know you guys are enjoying having fun because it's a long weekend, really long weekend, 4-day weekend. It's always fun. Okay, so it's a long weekend, so you guys are having fun. But we'll make sure that we continue with the fun in the class, okay, and try not to engage into any discussion, conversation which is happening in parallel. Otherwise, there's distraction, and that will not be good for the class. So, okay. So today I have just sent across the topics that we are going to cover in today's class, which is multiplying positive fractions and decimals, dividing positive fractions and decimals, adding, subtracting, multiplying, dividing integers, and dealing with negative numbers. And interestingly, none of these topics are new. This is part of the flow that we are following right now, right? So we are just going through the entire syllabus from 6th to 8th grade, and that is where we are picking up unit after unit. So basically, the topics that I talked about, multiplying, dividing, adding, subtracting, fractions and decimals, and then adding, subtracting, multiplying, dividing integers, and dealing with negatives. So these are the things that you guys would know, most of you, and we'll try to find out some of the interesting facts about what do we mean by doing it, and if there's something that you guys have forgotten or have not practiced enough, we'll try touching upon those aspects. So if it sounds boring, let me know, but it'll be something that is part of your syllabus, and we just need to make sure that we are not going wrong with those concepts. Okay, so when we talk about multiplying, dividing fractions, let me give you guys a very simple, not so simple problem to deal with, and see if you guys are clear, because this is just going to be a reinforcement of the concept that you guys know. If I say let me not make it complicated from a calculation point of view. So again, a very lame problem, but let's see who all can solve it right. 6 1 by 18 multiplied by 7 15 by 6 minus 6 by 18 plus 5 by 3 divided by 4 1 by 10. Yeah, somebody raised hand. Yeah, Dikshita.
What is the number below the 6?
This one?
No, the other one.
This one?
Yeah.
6 by 18.
Huh?
6 by 18. 18.
Okay, sir.
So it has 4 concepts in one problem. Meaning one concept is about the order of operation. So if any of you ignore that part, you could go wrong. Second thing is, how do you deal with mixed numbers versus fractions versus normal fraction versus improper fraction. And the third thing is about the division and multiplication of fractions / decimals, whatever it is called. So I want you guys to solve it and give me the answer in decimal. I want the answer in decimal. Because you guys will have enough reasons to say that this is boring. So that's why I'm adding spice into it. So solve it and give me the value in decimal. Everybody could see the question, right? I'm just reading it one last time for you guys, and then I'll go take a nap, wake up after 15 minutes and see who has solved it. Okay, so 6 1 by 18 times 7 15 by 6 minus 6 by 18 plus 5 by 3 divided by 4 1 by 10. Alright, see you guys after 10 minutes. No, you don't have 10 minutes, okay? 5 minutes. I was just putting some poor or dad jokes across. So I see Ritika also has joined. Hi Ritika. So everybody is trying that, right? Myra, you're trying that, right? Okay. And as we started from last class, in every class, first 45 minutes we will learn a topic, and then last 15 minutes we'll pick up a concept on geometry. So it's going to be more like a hybrid class where we'll learn two things together. Hello, Lakshita.
Hi.
So Lakshita, we are, I have sent out the topics for today, where we are going to talk about adding, multiplying, dividing, subtracting, multiplying, dividing fractions and decimals, and then we'll also talk about dealing with negative numbers and the similar operation with integers. And for last 15 minutes we'll cover some of the concepts on geometry. So that will be the pattern for next couple of months, where we'll learn some topics in the beginning, and towards last 15 minutes we'll pick up some concepts on geometry. So we keep on learning things in parallel. Yeah, Vivan.
So when I was doing it, like the decimal digits are getting kind of long. So can I just round it off to two decimal places?
That's the way to do. Yeah.
Okay.
So for Ritika and Lakshita, since you guys have joined late, so right now we see these concepts you guys know already. So what I'm doing is I have put a problem which has multiple concepts into it. Here you have order of operations, you have mixed numbers, you have how do you deal with the sequencing part of it, and then also how do you convert fractions to decimals. So this is 6 1 by 18 multiplied by 7 15 by 6 minus 6 by 18 plus 5 by 3 divided by 4 1 by 10. You have to solve it with all the concepts that you know, and this is just a way to check if everybody is comfortable, has practiced enough or not. And then once you solve it, convert that to decimal. That will be the answer that I'll be looking for. So kids who have joined late, this is the question, and I have given you guys next 5 to 6 minutes to solve it before I start doing something myself. Anybody who is not confident, and there's no shame in saying so. Okay, if somebody is not confident, that's okay. Lakshita, Ritika, try. Not trying?
Can you repeat that?
Yeah, no, I'm saying this is a question that I want you guys to solve. That is 6 1 by 18 multiplied by 7 15 by 6 minus 6 by 18 plus 5 by 3 divided by 4 1 by 10. So here a few things that you have to take into account. The order of operation, how do you convert mixed number into normal or proper improper fraction, and then how do you convert fraction to decimal. If these three things you guys recall, if you have practiced enough, you should be able to solve it. I'm waiting for some of you to solve, so that based on everybody's performance in the class, I will try solving it, or I'll let you solve. Yeah. So Sanvita, Ritika, Lokshita, Tanu, Praneeth, no, not Praneeth, Pranav. Everybody is trying, right? Gitesh? Okay. Okay, anybody done? Yeah, Pranav.
I got 14.33.
14.33. Okay. Okay. Dikshita.
I got 52.55.
Okay. Yes, Sanvita.
I got 14.03.
Okay. Nihan.
57.6.
Okay. Vivan.
I got 51.27.
Okay. Whoever has shared his or her answer, please put your hands down so that I would know if there's a new call out. Yes, Ritika.
I got 50.36.
See? Imagine a situation where I am being the teacher and who is evaluating the answer paper from all of you. How interesting the situation would be for me. Okay, we'll figure it out. Where is Arav and Advik? The two
We were
kids.
driving, so and then the phone's like there's like low internet connection, so
Okay.
we had to join from our times.
Okay, that's fine. So that's okay. There's a question to solve. I was asking where is Arav and Advik to give me the answer. Did you see the question? No. Okay, that's fine. So anybody else? Gitesh?
I'm still doing it.
Okay. Moira? Moira, you have to unmute. Huh?
I'm still doing it as well.
Okay, so see one thing now I probably cannot wait because every question that you guys come across, you always will have limited time for solving it. And if you are taking more time, that means either I'm getting distracted or I'm taking way too long for solving the problem. And both the situation will be unacceptable in the examination hall. As a teacher, I would say, okay, fine, I'll ignore what Myra sends or what Gita sends or what anybody who has not shared, right? But then for you guys, it will be a problem. So now the best option that I have is rub everything off, and you guys anyways have your answer with you. So we'll see who was close to being actuals. Now, interesting thing here, a lot of you would have spent a lot of time on the tables thing. Okay, and some of you who know the tables would have done it faster. Since I know the table of 18 6 are 108. So now what I'm going to do is break it down, simplify everything into normal fraction form, and then we'll see what we need to do. So here 18 6 are 108 plus 109 by 18. This became my first one. Multiplied by 7 6 are 42 plus 15. 52 plus 15. Sorry, 42 plus 15, 57 by 6. Okay, minus 6 by 18 plus 5 by 3 divided by 4 10 are 40 plus 141 by 10. Now here, always look for opportunity to simplify the things. All these big numbers are no fun. Okay. So now if you look at it, here itself I could have simplified this. 6 becomes 3 into 2. And then 57 is 19, 3 are 57. Okay. 57 is, 19, 3 are 57. Okay. So here, same thing, 6 and 18 also. Or let me not do it this way. Okay, this is not right. So once you have simplified, everything is like in a fraction form. Now your next attempt should be, let me simplify it so that I can deal with smaller numbers. Let's do that first. So this becomes 109 by 18. 109, no, I don't think I have an opportunity for breaking it down. I'll keep it like 119 by 18. Now you tell me, how did you figure out that you cannot break it down? See, 18 is 3 times 6, 18. So 3 and 6. Can this number be divided by 3? Anybody, do you know if it can be divided? No. Why? Yeah. Okay. Arif?
Because so basically the rule of the stability of 3 is add all number and it has to be divisible by 3.
Yes. Yeah. So since this is not divisible by 3, I am not touching it now. Here between these two, 57 and 6, this is divisible by 3 because 5 plus 7 12 and this is 6 anyways. So this is 19 times 3 is 57, okay. That comes from my knowledge of table, 3 into 2. Or else you can find out your ways. And then 6 by 18, I can write 6 into 1, 6 into 3. This became this. Plus 5 by 3 divided by 41 by 10. Now, what all simplified for me? This 3 and this 3 I can do tic-tac-toe, done. This 6 and this 6 I can do tic-tac-toe, done. So I have a much more simplified version of the problem that I was trying to solve. Let me knock off everything else and create some more real estate that I can deal with. So this becomes 109 by 18 into 19 by 2. Okay, much smaller number. Then this became 1 by 3 plus 5 by 3 divided by 41 by 10. Now here, this was just the simplification part where you converted your mixed numbers into normal fraction and then simplified it to some extent, and now you are trying to find out what do I do next. See, as per the order of operation, you know that you have to always do off or bracket, then division or multiplication, then you do addition subtraction. Meaning you have to first take care of this and this before you go on to this guy or do any addition here. Now this one, 109 into 19 by, So here, do you have a way to simplify it? No. So what you will do is you will multiply these two. It becomes 19 9 171. 19 1 19 plus 1 is 20. This became this. Okay. When you multiply this, this is what you will get. Let me not try to act smart. Let me solve it also. 9 9 81, 9 1 9, 1 9 9, 1 0 0, 1. Let's add it. 1 8 plus 9 is 17. 1 9 plus 1 is 0. 1 plus 1 2. Yeah, I was okay. I did not do a bad job. So I got my numerator as 2071 and then 18 to the 36 minus 1 by 3 plus, now I have to take care of these two, this division, and we know that division is all about diags. So I convert division to multiplication because I don't know division. So I converted division to multiplication and somebody danced. It flipped. This is what it became. So this is 2071 divided by 36 minus 1 by 3 plus, now let's see if we have a way to simplify it. Probably no. It will just multiply. 5 times 10 is 50 and 41 times 3 is 123. So this is what we have. Okay. So now you have a fraction, addition and subtraction together. So what we'll do, simple rule of thumb is find out the LCM of this. So 123, 3 and 36. We have to find out the LCM of this. I'll start with 3. 3 4 ja 12, 3 1 ja 3, 41, 3 1 ja 3, 12. Now here there is not much we can do. So I'll pick 12 because there is nothing in common here actually. Okay. So 41 remains 41, 1, it becomes 1 and then 41. So my LCM is 41 into 12 into 3. Okay. So 41 into 36. 6 1 is 6, 6 4 is 24, 3 1 is 3, 3 4 is 12. 6, 7, 4, 1. 1476 is my LCM. And now 36 when you take here, this one, 36 when you take here, it becomes 41 into the numerator, which is 2071 minus this one, 3 you take out, that means 41 into 12. So this is 41 into 12. And then you have plus 123. So this is 12 into 50. So this became 41 to 2071. So here between these two, you have 41 common. So take 41 out and you have 2071 minus 12 plus 12 into 50. So 12 5 is 60 and a 0. 1476. So I know this became a little complicated math, but that's fine. It's all about how you deal with numbers. So this becomes 41 times 2071 minus 12. So 2059. 2059 plus 600. So this is 41 into 2059. So anyways, okay. Since I made you guys do this sum, I will have to do it as well. So 9502, 4 9 is 36, 4 5 is 20 plus 3 23, 2 goes here, 4 2 is 8. So 9, 11, 4, 5, 4, 8. So 84,419 plus 600. So this becomes 85,000. 85,019 divided by 1476. Okay. So 85,000 divided by 1476. So it's like it has to be 85,000. So look at this. If I do a rounding here, I'm not trying to solve this. You can do that in calculator. But if I look at this, it is like 85 divided by 1.5. So it will be 1.5, little less than 60. So whoever got values near 51, 52, that's what would be the answer. If you got 14 or 8 or 20 or 16, that is nowhere close to being right. Okay? Yeah, Arav. You did not have the question. What you are talking about?
So, couldn't we just multiply everything with 18 except for 41 by 10? So then we can cut all this 18 and make it like a whole number order of operation?
No time for discussion. You can do all possible rounding. That's what I did. And I'm not saying that's the only way to round it. Okay? So I was just giving you a guesstimate. If once you have come to this one, you can figure it out, right? So it's like 85. This one you can do rounding and say 85,000. And then this one, if you do rounding, it becomes 1500. You guys know it what to do, right? Why do I have to even break it down? 5 3 is 15, 70, 170. 170 by 3. This is little less than 60 we are talking about. So this is a rounding thing. You can use calculator to get this value, right? Let's not spend time and energy on that one. That's what I was trying to say. Yeah, Dikshita.
The exact answer is 57.6 people.
Yeah. So again, here the idea is not to Arav. Okay, let's take a break today and spend 1 minute doing what do you call meditation. Okay, take a deep breath and control yourself. I will not entertain any nonsense in the class, okay, if I can say so, because Vivan, please don't do that. So any chatting, any parallel talks, any unnecessary display of smartness is not needed in this class, so that we can stay focused on what we do. All right, let's continue. So if you look at this one, right, so the first topic that we wanted to cover, or that is there for you guys for today, was making sure that we know how to deal with addition, subtraction, multiplication, division of fractions, and it was all there in one question. And I don't think I want to teach you guys again what is addition, subtraction, multiplication, division of fractions, right? Because you guys already know it, right? Unless somebody says, no, I'm not clear at all, wake up at 8:30 and join my class tomorrow. I'll explain you. Only if I have explained, you have not attended the class and you have not made the attempt from your side. If I have explained that 5 times and still you are wanting me to wake up at 8:30 for you, that is not fair. Okay? So wherever I have explained, and if you have a doubt, let me know. We can catch up. But otherwise, these concepts you guys already know. Okay? So I'm not going there. Anybody have any conceptual gap with respect to how to deal with fractions, decimals, adding, subtracting, multiplying and dividing a fraction? Anybody? I think it's Thanu who has joined with a different ID, right? Okay. Anybody have any doubt? If I say, let me just spend 2 more minutes. 24 by 18 multiplied by 6 by 19 versus 24 by 18 divided by 6 by 19. What's the difference between these two? I don't know. No. You talk a lot. I'll let everybody else talk as well. Vasundhara, do you know what's the difference between these two when it comes to doing operation with this? No opportunity for Advik and Arav. Even Dikshita gives me good response, so not for Dikshita. I'm just trying to make other kids also speak up. Okay. So Vasundhara, Myra, Ritika, anybody? What is the difference, main difference between these two? I know this is a Gitesh, if I don't tell you to speak, you will not speak forcefully, okay? I don't entertain that. Yep. Yeah, Ritika.
Like one of them is multiplication and one is division.
Yeah, no, that part you guys know. I'm saying what is the fun part here? What's the difference when it comes to operation? Arav, do I have to learn another language to explain you something? I said no texting, no unnecessary use of emojis. And that holds true for everybody. Yeah, Ritika.
Oh, I don't have anything to say. That's all.
Okay, let's see what Vasundhara has to say. Yeah, Vasundhara. What you will do differently when you're dealing with this situation versus this situation? Tanu, I know you know it. That's why I'm not letting you speak. Yep. Yeah, Vasundhara. Uh-huh.
It's like you're combining stuff.
Uh-huh.
Division, you're like splitting it into groups.
Right. Right. No, that's the conceptual part of it. No, I'm saying, see, when we learn something right in the class, I try to find out some fun element into it. So that's what I'm talking about. So Gitesh, okay, I'll let Gitesh speak up. I stopped him. Okay.
One of them is multiplication, one of them division, and one of them you have to do the reciprocal, and the other one you don't.
So I have been telling you guys that this is not math, this is dance. One form of dance, not Kuchipudi or Bharatanatyam or Odissi or in that form. It's another form of dance. When you have multiplication, you just multiply and get the value. When you have division, what you will do is, when you have division, this, you will say, I will not do division. I will still convert this to multiplication. And when you do so, there is a dance. Number flips. Okay. So that's the only difference. When you were trying to divide, see what happened. This is what I call as dance. And this dance form doesn't have a name. So what I'm saying is, multiplication, division are same thing. Only difference being, you never do division actually. You convert that to multiplication, and when you convert that, this flipping happens. Whether you call it dance, you call it somersault, or you call it something else, up to you. Yep. And then it's same as, once you convert this to division to multiplication, then you do it the same way like you will do a multiplication otherwise. Yeah. So you all know how to convert fraction to decimal, decimal to fraction, how to do addition, subtraction, multiplication, division of fraction. Now, one more thing. Converting fraction to decimal. Converting fraction to decimal. Everybody knows, right? Everybody knows. I'm not asking this question to Arav, Advik, Gitesh, Deekshita, because and Myra, Vivan and Pranav also, because you guys have heard it at least 15 times from me. Here also there is some fun element. Okay? And this is primarily for Sanvita and no, Gitesh, hands down. Let the teacher do his job. So this is primarily for Sanvita, Ritika and only Sanvita and Ritika. Okay. Here when you convert a fraction to decimal, any struggle that you have faced, or how do you do it? Yeah, Ritika.
Like you divide 6 by 18 and then you get the decimal.
Yeah. Now the problem is, I have to divide 6 by 18. And how do I do it?
You add like a decimal point and then you add like a 0.
Okay. So here the interesting part or the childish part of the math. here I call it chicken egg story, okay? I don't know who all in the class eats chicken. I'm not Arav, can you stop dancing for no reason? When I'm trying to explain to you guys, my focus goes on to Arav. Because he's always like doing dance. Stay stable, it's a math class. We'll have a dance class separately, okay? If you want to learn dance from me, I'll teach you the best form of dance also, okay? Alright, so coming back to this one. So, I'm trying to divide 18 by 6. 6 by 18. My problem is, this 6 is smaller than 18. That's where there's a chicken who comes to my rescue. And chicken has a very unique behavior. Chicken lays one egg at a time. I mean, in real world also, okay? You'll never see a chicken laying more than one egg, okay? I mean, so the chicken, the decimal is my chicken, which lays one egg at a time. As soon as I put a chicken here, it laid one egg. Now 60 is more than 18. 18 3s are 54. What is remaining? 6. Again 6 is smaller than 18. I said chicken lays one egg at a time. It will keep on laying one egg till we want. 18 3s are 54 again. 6. Chicken lays one more egg. 18 3s are 54. 6. And chicken will not get tired of laying egg. We will not get tired of doing the calculation as long as we want to do it. But with all this thing, what I was trying to say was, this decimal, what happens is, we learn that, okay, decimal, if I put a decimal, it gives me 1 0. And then, what we sometimes tend to forget is, it doesn't give 1 0, it keeps giving 1 0 at every step of the calculation. So as long as you keep that in mind, you'll be fine with your calculation. Yep. Anybody raising hand? Anybody having question on this one? About chicken thing? No? Ritika? Interesting, childish concept? Sanvita? Okay. So again, I'm not trying to promote chicken, egg or anything. Whoever eats whatever is up to their food habits or their choice of food. This was just a correlation. I mean, again, this is one dumb approach that I have just brought into this one, and I have gotten glued to that concept, so that's why I keep on talking about it. Okay, nothing wrong in the approach that you guys follow. This is just a funny way to memorize this. Okay. All right. So this was on the fractions, addition, subtraction, multiplication, division. Same way you guys have topic on adding, subtracting, dividing and multiplying integers. I'm not going there because I know you guys already know it. It's just a part of your syllabus. I'm not going there unless somebody comes to me saying, okay, I'm struggling. Okay, so I'm not going there. Now the next one is again negative numbers. When you talk about negative numbers, always keep in mind that if you're talking about negative number, you're simply talking about subtracting a number. If I'm, let's say 5 minus 3, 5 plus minus 3, if I say. If I'm adding a negative number, I'm saying that I'm actually subtracting it. And how you have to remember this is 5 plus minus 3. Or somebody says, okay, subtract minus 3 from 5. There is a difference, okay? Here you are adding 5 and minus 3. Here you are trying to subtract minus 3 from 5. Okay? That's the difference. I know I am giving a very simple example. Most of you will be knowing it. But be a little careful. When you are adding 5 and minus 3. Minus 3 is a number which is negative number. It's a money that I borrowed from somebody probably. No? If I relate that. And there is a difference between these two. How you will deal with this is, it's like breaking the bracket open. When you have to break the bracket open, you have to always remember, when you multiply similar things, you get a plus. So plus into plus gives you a plus. Minus into minus gives you a plus. When you multiply similar things, you get a plus. When you multiply different things, you get a minus. So here look at this same theory. Multiply different things, you'll get a minus. So this is when I'm breaking this bracket open, it becomes plus into minus. So 5 plus into minus becomes minus 3. Now you know 5 minus 3 is 2. You don't need any help. Here when you multiply similar things, it becomes plus. So 5 plus 3. So this is the only thing that you would need to keep in mind when it comes to dealing with them. Same way, it's always, whenever you're dealing with negative number, try keeping that in a bracket. So that way, you will not go wrong due to any human error. Let's say if I talk about 15 multiplied by minus 3. Don't write it like this, write it like this. So then you will know that, okay, I have to multiply 15 with minus 3. Now, when I don't have anything, that means I have a plus. So basically, we are talking about multiplying 5 by 3 and multiplying plus with minus 3. So that's how you will deal with it. Okay. Similarly, when it comes to dividing, you can always think of this as a reverse also. If let's say if somebody says divide 15 by minus 3. Why 15 and 3? Okay, let's say 45 by minus 3. So you are essentially talking about dividing 45 by minus 3. Now, here you have a negative sign, here you don't. If you don't have anything, you can always say this is plus 45 by minus 3. And here, 45 you can divide by 3. But how about this guy, the signs? What you want to do is, you can break this plus 4. You can break this into minus or plus into plus. Since I have minus here, let me do minus into minus. So I can write minus into minus. The plus that I have, I converted this to minus into minus, and then I have 45 by 3 minus. So this minus and this minus I can knock off. So see, now I have minus 45 by 3. And 45 I can write as 15 into 3. So this and this I can do tic-tac-toe. I have minus 15. Did it make sense at all? No? Yes? Okay. Okay. Ritika, Dikshita. And I will keep on putting Ritika on the spot because she is still trying to catch hold with my way of teaching things, right? This is only second or third class for her. That's why I'm just asking you, Ritika, okay? Otherwise, there's no other point. Yeah? So, what I'm saying is when you're talking about multiplying or dividing, the best approach is keep your minus in the bracket. That will give you clarity with respect to how you want to deal with it. See, as soon as we kept this in minus in a bracket, and we thought, okay, fine. If we divide this number, we'll get something in the numerator. But keeping a negative in the denominator is not a good idea. How do I find out ways to get rid of everything in the denominator so that I have only something in the numerator like this? So that's why we looked at breaking this sign also into two parts, because we know if you multiply same things, you get a plus, multiply different things, you get a minus. Or if I have a plus, I can break into 2 plus or 2 minus, or if I have a minus, I can break into two parts so that I can completely knock off what I have in the denominator. Yep. Is it making sense, Vivan? Okay. Alright. So this kind of reinforces that whatever we have learned with respect to how do we deal with fractions, addition, subtraction, multiplication, and integers or negative numbers. Let's spend next 15 minutes on geometry. So that is the new pattern that we have brought in, where we learn certain topics in a class, and then the last 15 minutes of the class we'll talk about geometry. So that way, because there are a lot of kids who keep reaching out to me saying, sir, do you teach geometry? And my response is, I teach maths, and geometry is a part of it. But then I see that many of you are taking classes or going for certain exams which needs extra focus on geometry. So that's why I just made that minor tweak so that you have two different topics that we cover in the class and it still remains fun for you guys. Okay. So till the last class, we were talking about properties of triangle. Then we briefly touched upon the four theorems, that is for congruence, where we talked about SSS, RHS, ASA and SAS. These are four theorems that helps you prove that if two triangles are congruent or not. And when you say congruent, we are saying that they are exact copy of each other. They are replica of each other. They have every matching property. They have same area. Okay. So we just talked about that. Now we are talking about area of a triangle. So we started with, and Ritika just stop me if I am going anywhere which is different from what we talked in the previous class. Be it Ritika, Vasundhara, Mayra, Dikshita, Pranav, anybody, okay? So we were trying to, we just talked about the property of the triangles, and then we are trying to see, fine, if I have a triangle or any shape for that matter, if I have to find out the perimeter, we are essentially talking about the length of the boundary. So this length plus this length plus this length. That is my perimeter. But how much space it takes is what is called the area of a triangle. And if I have a right angle triangle, how do I find out the area of this triangle? Okay, let's do one thing. This is a right angle triangle, 90 degree. And we also know, or we assume that area of a rectangle is length times width. This length times width, right? And if you ask me why, it's very simple, right? Let's look at a rectangle as a combination of squares. Let's say this is 4 centimeters. Okay, so this is 1 centimeter length, 1 centimeter width. So this is 1 centimeter square, and then this is 3 centimeter. So length is 4 centimeter, width is 3 centimeter. If you break it into smaller 1 unit squares, you will have 4 times 3, 12 small squares with 1 unit. If you have a rectangle with, let's say 5, length as 5 centimeter and width as 6 centimeter. So 1, 2, 3, 4, 5, 6. So you will see that you have 5 into 6, that many squares of 1 unit. Every square, I am calling it 1 centimeter square because the length is 1 centimeter. Okay. So you will see that the rectangle 6 into 5, you have 31 centimeter square. If you are talking about a 4 into 3, a rectangle, you have 12 1 centimeter square. Okay. Similarly, if you have 7 into, let's say 7 centimeter into 6 centimeter, you will have total 42, 7 times 6. See, this has 12, 4 times 3. This has 30, 6 times 5. So if you have 7 times 6, 7 length and 6 width, you will have 7 to 6 1 centimeter squares. Okay. So that is how the area of a rectangle becomes, and then every square is 1 centimeter, 1 centimeter. It's called 1 centimeter square, meaning the square with side as 1 centimeter. Okay, it's 1 centimeter square. So this is how the area of a rectangle got represented in terms of that small unit squares, and it gave birth to a formula called area of a square of rectangle is nothing but length times width. Okay, is that relatable? Everybody with me?
Yeah.
Okay. Now, so area of a rectangle is length times width. Now coming back to this triangle, we are trying to find out the area of this right triangle. What I will do is, I will just extend this line parallel to this line. and then extend from this point a line parallel to this line. And when I join them, I see that it became a rectangle because this side will be parallel to this and this side is parallel to this. I'm still saying parallel, I did not say equal. Okay? Why? Because I'm saying that this is a right angle triangle, and by drawing parallel lines, this is also right angle triangle. And I'm trying to figure out if this right angle triangle and this right angle triangle have the same area or not. And this is where, when you're dealing with right angle triangle, this theorem of congruence, RHS, says if it's a right angle triangle and your hypotenuse of both the right angle triangles are same and one of the side is same, then they'll be congruent. Or I can say if one of the side is same and two of the angles are same, then they are congruent. Basically, what we are trying to figure out is if this triangle and this triangle are congruent or not. If they are, then I would say, okay, this area and this area are same, which will be half of the area of this rectangle. Okay, so half of this area of this rectangle, which will be length times width. Or if I call this as a length, this is a width, this will be length times width. Or I will say if I call this as a base and I call this as a height, it will be base times height. Okay, so I'm just trying to find out these two are congruent or not. Now, interesting thing is, when you draw parallel lines, okay, you will have, when you have this line parallel, that means this angle and this angle will be same. Okay, now you look at these two lines as parallel lines, then this angle and this angle will be same. This is a property of parallel lines. Let's quickly touch upon that also, because if you guys don't recall that will be a problem and you will be forced to believe what I'm saying. Let's say I have a pair of parallel lines. If I have a third line intersecting it, then these are called corresponding angles. Meaning the angle that is, both the angle that is on one side of this intersecting line and above the lines. This is 1 and 1. These are called corresponding angles. Similarly, this angle and this angle are called corresponding angle 2, because both are below the parallel lines and on the right hand side of this line. Similarly, this and this, if you call 3 and 3 are called corresponding angle as well. Again, both have the same behavior, both are below the parallel lines and on the left hand side of the intersecting line. This angle and this angle is also called corresponding angle because both are above the parallel lines and on the left hand side of the intersecting line. Yeah. So these are called corresponding angles. So this is a property of a parallel line. When you have a pair of parallel lines and the third line intersects them, then your corresponding angles are same. Okay? Is this part okay so far? Yeah?
Yes, sir.
So now look at this. Your corresponding angles are same. Meaning this angle 1 and 1 are same. Angle 1 and is equal to angle 1. Now I want to give you guys a surprise and say angle 1 is also equal to angle 3. Would you guys believe that? Angle 1 is equal to angle 3. So here you have angle 1, here you have angle 3. Here you have angle 1, here you have angle 3. Yeah? I am saying they are same. Would you believe that? Rihan. Yeah, Ritika saying something?
Yeah, like wouldn't they be like equal by like vertical angle?
Not vertical angle. See, look at this. Imagine this. Now you should look at 1 and 3. Imagine this as these two line segments meeting at this point. Okay. This angle and this angle I am saying same. Why? Because see, these are opposite angles. What is angle? Angle is the inclination between two lines. This is the angle. Yeah. Now think little bit further. Now these are two lines or line segments. Here where you are seeing my face, right? This is one angle. And then this side between this palm and this my wrist, right? This is another angle. So where you are seeing my face and this side, these are same angle because the inclination between the lines is the same. Just that you are looking at it from other side. Correct? No? So again, I know it needs little bit of visualization, right? So look at this. If I say this angle is some value, okay? Yeah, Rihan.
Wait, what if the X is kind of like the X formed from the two lines are kind of like tilted?
No, so wait for it. Let me help you guys visualize this. This is my angle, okay? Let's say this is 60 degree. Everybody has to hold their horses for next 5 minutes, okay? Now 5 minutes or maybe 2 minutes. I know it's already time. We'll probably cover the rest of it in the next class also. That's okay. But just look at this part. This angle, if I'm saying is 60, this angle will be 60 as well. Why? Because see, you are looking at the inclination between the lines from this side. It is 60. You rotate your compass and look at this inclination. It's the same inclination, right? It's the same inclination. You're just looking at from this side, your eyes are this side, and now your eyes are this side. That's it. But the inclination between lines is same. If you look at this place, this place, this place, the angle is same, right? The distance between lines doesn't make a difference. It's about how they are leaning against each other. Yeah? One exercise I have for you guys. What you can do is just randomly, okay, draw two lines, line segments like this, and take the compass to measure this angle and measure this angle. If you find these two angles being different, let me know. We'll talk about it tomorrow. Yeah? Very small fun activity. Just draw two lines, measure this angle. I hope everybody knows how to measure the angle using compass. And then measure this angle. These are called opposite angles, okay? And they are always the same. Just measure this and let me know tomorrow in the class if the angles were same or not. And make sure that you are not relying on your skill like the way I am drawing it right now. Use scale for measuring it, okay? I mean drawing it. Use a ruler for drawing the lines, okay? Otherwise you are drawing by hand and then you are challenging me saying, sir, no, my angles do not match, then there is a problem. Yeah, Pranav.
So, are the other two angles the same as the angles that you showed?
Yeah, these two angles will be the same. This angle and this angle will be the same. Okay. So I was showing it with respect to this line. Okay. That corresponding angles are same. Meaning this angle and this angle are same. Now the other flavor I am trying to bring here is that this angle and this angle are also same because this is one. Let's say this is 60 degree. I am saying by the definition of the parallel lines, this will be 60 degree. Now I am saying if you look at this angle and this also has to be 60 with this concept. Your opposite angles are same. See, visualize this as these two lines meeting here. If this angle is 60 degree, this has to be 60 degree as well. So in terms of parallel lines, when you talk about the property of parallel lines, you know that the corresponding angles are same, that is given as a base concept. And then the opposite internal angles are also same. That's the second concept that we are trying to derive based on the basic property of parallel lines. Yeah? So let's not get stressed out right now. I have no plans to extend this class. I only want you guys to use your ruler to draw two lines where they intersect at some point. Measure this angle and tell me how much it is. Measure this angle and measure this angle and tell me how much this is. This angle should match with this one and this should match with this one. If it doesn't, there is a problem. Yadrik.
And all of them equal 360?
that's an information which I am not really worried about. Okay. What we see, always look at what is the focal point of discussion right now. What we are concerned about right now is finding out the relationship between these two angles, which are opposite angles, or this angle and this angle, which are opposite angles. Okay. Whether this and this together is 180 or not. If it's 180, wonderful. If it's not 80, I don't care. Yeah. Alright. That brings us to the end of the class. Let me stop recording it.